Okay, so obviously that first video just kind of defined a little bit about what stoichiometry is, and again, really just so that you're not overwhelmed or nervous about such a crazy big word, stoichiometry. Let's go ahead and take a look at something that's important to know, and that's the mole conversions. You recall from last unit. Actually, let me get out of this for a second here and get some lighter colored tools. That should be good. Okay, sorry about that. So mole conversions. You remember from last unit, hopefully, whoops, that we can convert between moles and mass in grams, volume in liters, and particles. And of course that could be molecules, atoms, formula units. Okay, and our conversions here, let's see if we can get another color that's a little easier to see. All right, our conversions was 1 mole was always equal to the periodic table in grams. You'd have to look it up. 1 mole was always 22.4 liters for gases at STP, and 1 mole is 6.02 times 10 to the 23rd particles, Avogadro's number. So those were our mole conversions. Nice little reminder, little review. If I were to convert from one to another, again, I'm a big fan of going to moles first. All right, so if I give you a quick example, we have 15 grams of nitrogen. Let's make it nitrogen. 15 grams of nitrogen. And I want to know how many liters that is. We would simply X line, grams, moles, 1, 28, because nitrogen is 14, and we have 2 of them, N2. So I've got a calculator right here. Let me quickly do it. 15 divided by 28, 0.53 moles, X line, moles, liters, 1, 22.4. And again, if you watch the previous videos, you know that I'm a big fan of the whole X lining and then filling in numbers. And we're going to multiply that by 22.4. So right around 12 liters of nitrogen. Okay, so this mole conversion, very important to remember. Now, I just kind of created this little flow chart, but I want you to see that it's very important here for this stoichiometry if we're going to be able to compare amounts of one versus another. And so let's say I have the moles. We should be able to go from grams, liters, or particles to moles. Again, setting up your X line and all that type of stuff. All right. We also should be able to go from moles to grams, liters, and particles. Okay, and I just showed the little flow chart where it was kind of the arrows going both directions. But obviously it's the same thing. We can go from grams to moles, and we can go from moles to grams. It's just depending on which conversion factor we would use, okay? The key here for this unit and stoichiometry is how can we compare A here, this yellow moles, with B? One thing with another, okay? 2 cups of flour with 2 cups of sugar, okay, the comparisons. So what we're going to be looking at here is the conversion between moles of one to moles of another. And that's really the whole nuts and bolts of stoichiometry, okay? And again, I give another, if you don't mind, I'm going to give another kind of analogy. I think it does a pretty good job of explaining some of this, all right? If we've got moles of one to moles of another, here's a picture of Google Earth of Kittery, Maine. Kittery, obviously, over on this side right here. And of course, this is, it's hard to see the letter here, Portsmouth. Portsmouth, New Hampshire. Okay. Obviously, for those of you that live around here, this is the Piscataqua River separating the two. Okay, so Kittery and Portsmouth. Now, what we're basically, and I want you to think of an analogy, is whether or not you are in, and if you know the area, you're in Elliott or York or Kittery Point, okay? Let's pretend that the only way to cross the border from Maine to New Hampshire is that one bridge. Okay, we have a couple more bridges, but let's say that there's only one. Doesn't matter if you're in any of these three areas, Elliott, York, Kittery Point, you would need to come to the front of that bridge. Okay? And then once you got on that bridge, you could cross the bridge, and then you could go on your way to, let's say, Newington or Rye or Greenland, let's say, all areas in Portsmouth. Okay? So again, the point being that this bridge is the real key, and we must get on it and we must get off of it. So no matter where we are, we get to the front of that bridge, cross the bridge, and then we could be on our way. So that's the analogy I'm hoping you can see as we go through moles. Because when we go from moles of one to moles of another, really that's the big nuts and bolts for stoichiometry, comparing one with another. All right? Here's another analogy, Confederation Bridge. If you know again about our area here, this is Maine. Okay, you know, obviously, whatever, it's kind of right up in here. Not a very good drawing, but this is New Brunswick in Canada. And right over here is Prince Edward Island. Well, it's obviously an island, but there is a bridge, Confederation Bridge. And so, let's take a look at that. And again, I'm doing a little geography here as well. I'm a big fan of geography and whatnot. Confederation Bridge, you can barely see it. It's a little bridge here connecting mainland New Brunswick with PEI. All right. Now, no matter if you were in Maine, if you were in, New Brunswick, or if you were in Massachusetts, if you wanted to get to PEI over the bridge, you would come to the front of that bridge, then cross it, and then you could be on your merry way to anywhere in Prince Edward Island. Okay? Again, you've got to get to the front of that bridge, and then you can go off. So again, that's the analogy I want to make. You can see the numbers. I put a few things up there, Confederation Bridge, about $1 billion, 8-mile long bridge in the middle of the ocean. And I just throw it up here. The big dig is well over $22 billion. This is in Boston. So anyway, there's the big Boston part of the bridge is in Big Boston, in Boston. All right. So let's call that good. Again, just kind of giving you the idea of moles of one to moles of another.